Welcome to C&EN Uncovered. I'm Craig Bettenhausen. C&EN Uncovered is a podcast series from Stereochemistry. In each episode, we'll take another look at a recent cover story in chemical and engineering news and hear from C&EN reporters about striking moments from their reporting, their biggest takeaways, and what got left on the cutting room floor. In this episode, we're talking about a recent cover story that asks the question, can tires turn green? Which appeared in the May 29th issue of C&EN. We'll put a link in the show notes. I'm here with C&EN's European business correspondent, Alex Scott, who wrote that article. Hi, Alex.
Hi, Craig. How you doing?
Doing all right. So for the folks that haven't had a chance to read the article, can you give a brief kind of overlook of what the story's about?
Yeah, it's about the sustainability of tires and how that is changing, and looking at the different life stages of tires, from how they're manufactured, what greenhouse gas emissions may come from that stage, and then looking at the use, so what particles come off the tires and what effects they may have, and also looking at recycling and end life of tires and what's changing in that area as well.
So from a high level, I'm familiar with the giant piles of tires outside of my city, but beyond that, I don't know much about how tires are normally dealt with. What is the normal fate for a tire after it comes off of my car?
Well, there are lots of different uses, but more than 50% of waste tires end up either being incinerated or still end up in landfill. And there are various issues with both of those. On the incineration front, there are huge greenhouse gas emissions that result from that. And in landfill, as well as covering huge areas of land, you can get leachates from some of the chemicals coming through. They can end up in groundwater, and that can be a problem as well.
So in your story, the vector for pollution from tires are these tire and road wear particles, TRWPs.
Mm-hmm.
One question I had was, how do they move? Are they airborne? Are they mobile in the water? How do they get from the road to the farms and fisheries that you mentioned in your story?
Yeah, that's a very good question. So on the one hand, you've got not just the particles themselves, which tend to be on average about 100 microns in length, but you can also get much smaller particles, nanoparticles of the tire material, which can be airborne. And obviously, they can end up being transported long distances. In terms of the fate of the bigger particles, which end up on the road, they can be washed into drainage systems, and then from there, they can be washed into rivers. The fate in water systems is really not well understood. Some studies estimate that up to 28% of all microplastics in the oceans are made up of tire particles. But other studies, including one from the Open University of the Netherlands, puts that estimate between 5 to 10% of all microplastics entering the ocean. So it really depends on the location. Some river systems are going to be closer to roads. So it's very difficult to tell the exact numbers and the exact regions where the problem is the worst. Also, another route would be looking at wastewater treatment systems, and a lot of tire particles can end up being collected by these wastewater treatment systems. And in some cases, the sewage sludge, this is the solids from these systems, they can end up being put onto agricultural land. So there is a potential for some tire particles to end up on this agricultural land, and potentially in foods as well.
So microplastic accumulation in the sea and on land, that's intuitively, we can kind of understand why that's bad. But these TRWPs, they have some specific chemical compounds in them that are problematic. The article focused on 6-PPD, but there are also some others, right?
Yeah, there are. 6-PPD is an antioxidant, so it's a really important chemical for making sure that the tires last a long time, that they're safe, that they don't crack. Some studies from the industry show that if you didn't have chemicals such as 6-PPD in the tires, that the tire wouldn't last much more than 1,000 miles, maybe 100 to 1,000 miles, I think they say. But you've got the problem that chemicals such as 6-PPD could also be causing acute toxicity issues for certain species. So 6-PPD itself has been linked to the mass death of coho salmon on the west coast of the US, and this is something that's been happening for decades. And this study has only just made the link in the last couple of years. So 6-ppd is certainly something that needs to be further addressed, further investigated. But there are also other compounds. You have zinc, which is used in the vulcanization of the rubber to make it hard. And there are also other aromatic hydrocarbons in tires, which are potential carcinogens. So there's a huge number of different chemicals, different compounds, which could have potential environmental impacts, but we don't really know yet the extent of those impacts.
It's interesting that 6-ppd is an antioxidant. You usually think of that as something you do want to consume, but not this one.
No, definitely not this one.
So what options are there for preventing these particles from getting into the environment?
So there are a number of ways that you can mitigate. There's actually one thing that I didn't get to include in the article is that there are some capture devices which you can attach to vehicles which actually catch the particles as they're coming off the tires. So there's a London-based company called the Tire Collective, and they've got these devices which have been shown to, which are prototype, but that have been shown to significantly capture the tire particles as the car's driving along. Another area where you could try and capture the particles before they get into the environment where they could be causing harm is by having something called porous pavement. So this is, as it sounds, the tarmac on your road being much more granular so that it has pockets in it where the particles can remain. But the question there is, once it's full, if you don't have a road sweeper coming along cleaning it out, then if you've got big rainfall events, are all those particles going to get washed into the river system anyway? So there are certain questions about that. And again, it's really at an early stage of trying out these kind of technologies.
When I go to fill the air in my tires, I always get this black stuff on my fingers. I don't know what that is, if that's carbon black or these tire and road wear particles or just grime. But it makes me wonder, what are the ingredients in tires?
Part of that is going to be carbon black, which is makes up a big part of the tire. But you've got sometimes around 100 different ingredients that go into tires, 100 different compounds. So you've got a lot of rubber, obviously goes in there, some of that natural, some of that synthetic. Carbon black, which, as the name suggests, it's a carbon material, and that's used as a filler. So those are the two main ingredients, and then you've got these other additives that go in there, such as oxidants, such as the 6-ppd that we discussed, and other materials also go into there to improve the rolling efficiency of the tire, to make sure that the friction is lower so that you get more fuel economy out of your tires. It's a whole gamut of different materials going in there. And that's one of the reasons why it's so difficult to say, well, if 6-ppd is a problem, why not just take it out and put something else in? Because you could be affecting those 99 other compounds in the tire if you replace it with something else other than 6-ppd. So it's not something that is very easy to do at the moment.
So speaking of sort of changing the recipe, your story also goes into new and expanded bio-based content in tires. And that sounds good, but I know that in conventional recycling, sorting is a huge issue because the different types of plastics can't be recycled together. So how does the bio-based tires, can they be recycled in the same streams as conventional tires, or is that another complication being added?
No, that it's actually very simple. So the new technologies emerging that can chemically recycle tires, they use a process called pyrolysis. And this essentially is where you grind down the tires into crumbs, and then you put it under heat without oxygen. And this creates a gas for much of the material and creates a solid for the carbon black that we talked about earlier. So the rubber is gasified, and then that can be cooled into an oil, and that can be used to remake tires. So the whether it's bio-based rubber or synthetic rubber doesn't really have a huge issue on the recycling process itself.
Interesting. So when you're doing that, how much of the mass of the tire are you able to recover? How efficient is that process?
So it depends on which company you talk to, because lots of different companies are looking at ways of recycling using pyrolysis. And there's even a company that is developing a bio-based process using synthetic biology.
So like a microbe that would eat the tires.
Yeah, essentially, yeah.
Huh. Right.
And then you would be able to recycle it into the chemicals, including butadiene, which is a main raw material for going back into rubbers. So again, that's at an early stage, but it's at a really interesting opportunity there.
So it seems like there are some solutions on the horizon, but I noticed that some of the targets are more modest and are farther off than some of the sustainability goals you see in a lot of the chemical industry. How long till these things that you're talking about in this article are going to reach a scale where they can make a difference?
Well, I think the recycling part of it is actually going to be coming pretty quickly. And the reason for that is that you can reduce the costs associated with producing the raw materials if you're going to be adopting the recycled material versus the virgin material. And the part of that cost is because, such as in Europe, you have to pay for your greenhouse gas emissions. And the greenhouse gas emissions for some of the recycled materials, such as carbon black, can be up to 80% less than for virgin materials. So this is a significant difference, and that's really going to start having an impact on the actual cost, because 1 ton of carbon dioxide in the European Union costs you about $100. When you add that up at the company scale and at millions of tires scale, you're really talking about a significant cost difference.
Does that reach all the way down to the consumers, or is it more affordable for you personally to buy this material?
Now there is a very good question, Craig. I think we're talking really at the higher end, at the manufacturing end.
Okay.
Whether that trickles down to the consumer is a matter for the industry, I guess. We'll see.
Now, are there some other tidbits and tangents that didn't quite make it into the story that you wish you could have fit in somewhere?
Yeah, I think that obviously one of the changes in the automotive industry is that we're starting to adopt electric vehicles. And one of the interesting things there is that electric vehicles tend to be heavier than their combustion engine counterparts. And this means that you are going to have different tires, because you're going to need stronger tires so they don't wear out so quickly. And that means having more antioxidants, so more materials such as 6-PPD in the tires. And another trend also along that line is that if you're having more biobased rubber, the same thing applies. You're going to need more antioxidants to hold the tire together. So potentially, again, with that coming in and with the industry trying to use more bio-based materials, you're going to need much more antioxidants. So that's obviously not something that you want to do if you've got environmental impacts from your antioxidants. So there's a challenge there for the industry and for regulators to work out how the balance should come out and what's best for the carbon cycle, what's best for local toxicity, and obviously what's best for the industry as well.
Yeah. So you posed the overall question in this article of, can tires turn green? What expectations do you have that the industry is going to be able to get to these sort of completely sustainable tires?
Let's put it this way. When I started out on the article, I thought, it's pretty straightforward. The industry is gradually getting greener. And with these new recycling technologies, it's going to be a done deal in a few years' time. But it's really complex. Your tires have to do so many different things. If you think of safety, tires have to stop at a certain distance. They have to perform in the wet and in the dry. And they have to be able to keep this high pressure air, maintain their shape, not to blow up when you're driving along at high speed, basically.
Yeah.
So they've got all that to do. And then there are these sustainability and environmental demands. It's really complicated. And as one of the researchers from Imperial College London told me, he doesn't expect the tire industry to do anything until there are regulations which come in to actually make them do something. So I'm not sure it's an easy task for the industry, but it's the recent evidence on 6-PPD and other materials and tires would suggest that something needs to be done sooner rather than later. When that will actually be done, when regulations will come in, I don't know. But my sense is that there is more and more understanding in this area. And as that understanding grows, there will be more pressure on regulators to do something about it.
Well, Alex, I want to thank you for taking the time to tell us all about this. It's interesting stuff.
Thank you. And I really appreciate being able to explain a little bit more about the article.
So you can find me on social media as @CraigofWaffles.
And you can find me, Alex Scott, on @AlexScottCE News. And if you'd like to send me some questions on there, I'd be happy to answer them.
So you can find Alex Scott's cover story about sustainability efforts in the world of tires on C&EN's website or in the May 29th print issue of C&EN. We put a link in the show notes along with the episode credits. We'd love to know what you think of C&EN Uncovered. You can share your feedback with us by emailing CENfeedback@acs.org. This has been C&EN Uncovered, a series from C&EN Stereochemistry. Stereochemistry is the official podcast of Chemical and Engineering News. Chemical and Engineering News is an independent news outlet published by the American Chemical Society. Thanks for listening.